Hi friends, let's continue our discussion with another example. In this case, we have three resources A, B and C with instances 6, 3 and 4 respectively. And in the current situation, we have three processes P0, P1 and P2, and these are the instances of A, B and C allotted to these processes, and these are the maximum requirements given by the processes for the three resources A, B and C respectively. So these are the allocated, and these are maximum available, and hence at the current situation we have one instance of A, nothing is left of B, two instances of C are available. So looking at maximum need and current allocation, this is what is yet to be allocated so that the processes can continue. So 201 for P0, 011 for P1 and 112 for P2. Let's see how can we proceed further. So that's a same table copied here. Let's begin our journey. So we are currently available with 102 resources of A, B and C respectively. Then let's begin our process P0. P0 requires 201, that means 2 units of A, but we have only 1 unit of A and hence not possible to continue. So P0 cannot be taken up at this instant till some process completes its job and releases the resources. P0 cannot continue. Okay, let's check with P1. P1 requires 011, so A it doesn't require, it needs one instance of B, but problem is we don't have any instance of B left with us, therefore this 011 cannot be given, because though A is not required, not issue, C we have 2, we want only 1, so that can be taken up, but the problem with B is it is not possible to give one instance of B, and hence this requirement also cannot be taken up. So we cannot allot this 011 instances to P1, and hence P1 also cannot continue its execution. And since P1 cannot continue its execution, the allotted resources 311 are still with P1, none of them will be released. Now let's check, can we continue with P2? Same problem with the P2, that means it also requires one instance of B and we have none, and hence P2 also cannot continue. So P1 cannot continue, therefore these 111 cannot be released, P1 cannot continue, and hence 311 resources cannot be released, and P2 also cannot be completed, therefore this 110 held by P2 also cannot be released. So none of the resources can be released because none of these processes can continue. So if you just look at that, P1 wants 1 unit of P, and that may be possible if P0 completes its job, that one instance of B can be released, or if P2 completes, then one instance of B can be released. So we can say that P0 is waiting for either P1 is waiting for either P0 or P2. Same way, if you look at P0, it needs 2 instance of A, whereas we have only 1 instance of A. Therefore either P1 should complete or P2 should complete, only then some instances of A gets released, and therefore P0 is waiting for either P1 to complete or P2 to complete. Same way, if you want look at P2, then P2 is waiting for one instance of B. So for one instance of B to be released, either P0 should complete or P1 should complete. So if you just look at that, P0 is waiting for P1 or P2 to complete, and P1 is waiting for P0 or P2 to complete, and P2 is waiting for P0 or P1 to complete. So they are waiting for each other to complete, and hence none of them can complete and that's what we say, the situation is unsafe. So these allotments cannot be given, because if we allot these, then definitely it is going to lead to deadlock. So that is how we just try to understand whether allotting any resources will lead to deadlock or not. That's how the banker's algorithm is used. So that's it for now. Thank you.